The notes in this video are for Learning Target 3 in this unit. Learning Target 3 says I can use function notation to evaluate a function for a given value algebraically and graphically. In this video, we're going to be evaluating functions algebraically. So when you think about a function, we can think of it as a machine. And this machine assigns each input to one output. This is an example of a function. And this function is called f. That's the name of our function. You'll usually see functions that are called f, or g, or h. They're called any letter, typically a lowercase letter. In parentheses here, this x is our input. So we know that's a domain value. And when we put this together, f parentheses x, we say this as f of x. And it means our function evaluated at x. When we are evaluating that function, we're following this rule here on the right. And when we follow that rule, when we substitute a number for x, this is also how we would get our output. If we use this function machine to find f of 2 and f of -1, we're using this rule right here, this f of x rule. So we know when we put a number into this machine, it gets multiplied by 3, so 3x, and then added by 4. So if I put in positive 2, I would be doing 3 times 2, which is 6, plus 4, would give me an output of 10. When I input -1 to find f of -1, -1 goes into the machine. I would do 3 times -1, which is -3, and then add 4 to get an answer of positive 1. We're going to be writing our workout a little bit more formally for these, but this just gives you an idea of what happens. You put a number into the function, some stuff happens, and you get another number back out of your function. So if you flip to the examples on the inside, we'll be doing these examples in the video, and then you'll be trying the problems on the next page on your own. So we have two functions here. They ask us to let f of x equal x squared plus 3 and let g of x equal x plus 1. So we have two functions that are doing two different things. In my f of x function, I'm squaring my input and then adding 3. And in the g of x function, I'm taking my input and adding 1. To write this out formally, if I'm evaluating f of 3, I would start by saying that f of x equals x squared plus 3. I would rewrite the problem. And if they're asking me to evaluate f of 3, they're saying I'm inputting 3 anywhere there's an x in this function. So now instead of saying f of x, this would say f of 3. And instead of saying x squared, it would say 3 squared. So f of 3 equals 3 squared plus 3. Now I can evaluate what's happening on the right side of my equation. 3 squared is 9 plus 3. So f of 3 equals 9 plus 3. So f of 3 is equal to 12. So the number that we put in was 3, that's our x value. The number that we get out is 12. So that's our y value. Our outputs are our y value. So as a point on a graph, I could write this answer as 3, 12. I put in 3, that's x. I get out 12, that's y. When I evaluate g of 0, I'm going to start the same way by rewriting the function. G of x equals x plus 1. They're asking me to put in 0, so anywhere I have an x, I need to substitute 0. So g of 0 equals 0 plus 1. So g of 0 equals 1. As a coordinate pair, this one would be 0, 1. I put in 0, I got out 1. The next two problems take this up a notch. This one says 5f of 4. What this means is that we're going to evaluate f of 4 and multiply the result by 5. So I'm going to start this problem by finding f of 4. So I'm going to go up to my f function. My f of x function is x squared plus 3. And I'm evaluating this for 4. So I would have f of 4 equals 4 squared plus 3. So f of 4 equals 4 squared is 16. 16 plus 3 is 19. I'm trying to find 5 times f of 4. So that would mean 5 times 19, which would be, oh, I need a calculator. 95? Yeah, 95. For example 4, they're asking us to evaluate two functions. First, we're going to evaluate g of 3. Then we're going to evaluate f of 0. And as our last step, we're going to add those two answers together. So I'll start by evaluating g of 3. My g of x function says g of x equals x plus 1. I'm trying to find g of 3, so I would be doing 3 plus 1. So g of 3 is equal to 4. Now I need to find f of 0. So I'll start by rewriting my f function. So f of x equals x squared plus 3. I'm evaluating for 0. So anywhere I have an x, I substitute 0. F of 0 equals 0 squared plus 3. 0 squared means 0 times 0, so that's just 0. And 0 plus 3 is 3. So f of 0 equals 3. Now they asked us to add those two results together. So g of 3 plus f of 0, well, g of 3 is 4, f of 0 is 3. So our final answer is 7. For example 5, we're evaluating the function f at b, which is kind of weird. We're not inputting a number here. We're inputting a variable. I start my problem the same way as all of the other ones by rewriting the function. And usually this is where I would put in a number and do some math to find an answer. In this case, I'm not putting in a number, I'm putting in b. So I have f of b equals b squared plus 3. I can't evaluate this any further. I can't change anything about this because I don't know what number b represents. So my final answer is f of b equals b squared plus 3. For our very last example, we have this function called k of x, and k of x equals x squared minus 3x. We need to find the value of k of 5. And we've got some multiple choice options here. So if I'm trying to find the value of k of 5, I start the same way as every single other problem. I'm going to rewrite the function k. And now anywhere there's an x, I need to input a 5. So I'll have k of 5 equals 5 squared minus 3. And where I have this x right here next to the 3, I'm going to put my 5 in parentheses. Because when they're asking me to input 5 here, I know that means 3 times 5 and not 35. So we need to make sure we use parentheses so that it looks like a multiplication problem. Now we're going to follow our order of operations, which says I should do my exponents before I multiply. So 5 squared is 25 minus 3 times 5. My next step would be this multiplication problem. So 3 times 5 is 15. And last step, I can subtract. K of 5 is equal to 25 minus 15 is 10. So as a coordinate point, I put in 5. My input is my x value. I got out 10. My output is my y value. So this would be 5, 10. So the value of k of 5 is C. So now I want you to try the problems on this next page. The last one is a little bit of an extension. It's a little bit more of a challenge than the other problems that we've done. Once you've gotten these problems complete, check in with me so I can check your work.